Welcome to my video. In this video we're going to talk about Jupiter and his main four largest moons, Io, Europa, Ganymede and Callisto. Now Jupiter is the biggest planet in the solar system. It has over 300 times the mass of the Earth and it has the shortest day of any planet in the solar system. One day is about 10.5 hours. Now Jupiter formed from the cloud of gas and dust that made the solar system. Basically when the sun was forming in the center while the debris disk was basically around it, and some pockets in that debris disk became to coalesce into bigger and bigger rocks. Those rocks coalesced together and then you got protoplanets. From those protoplanets the proto-Jupiter was formed in a way, and that proto-Jupiter started to go even bigger and bigger and bigger. Now his mass was only about 20 times the mass of the Sun at that point. However, he began to accumulate gas, hydrogen and helium around it, and he was able to develop an atmosphere about 2,000 kilometers thick, which basically is what we see as Jupiter today. Now Jupiter also is basically one of the most extreme planets in the solar system, with wind speeds of about 480 kilometers per hour, huge storms, a crazy magnetic field, and what's even more interesting, it's basically like a miniature solar system with between 75 to 200 moons around it, which most of them are just smaller objects that were caught by Jupiter's gravity over time. Now when Jupiter and Saturn first formed, they were going around the Sun in regular orbit, slowly and steady, but eventually they got into a specific point in their orbit which allowed them to go into what we call orbital resonance. In this orbital resonance, or there is a name for it, I'm trying to remember. This thing means that the planet Jupiter and Saturn, which are also very big planets, which we're going to talk in a different video, are basically going into harmonious orbits, which means for every one orbit around the Sun that Jupiter did, every one orbit that Saturn did, Jupiter did twice, which means 1:2 ratio. And that created havoc in the early solar system and created an event that called the Late Heavy Bombardment, which flown a bunch of comets and asteroids into the inner solar system to Earth and the inner planets. Now Jupiter, of course, is a gas giant. A gas giant means that this planet is basically made from hydrogen, 90% or so, helium close to 10%, and some percentage of different chemicals like ammonia, water, and a bunch of other gases, so to speak. Now, Jupiter, just like Saturn, has a ring system around it, but we can't see it because this ring system is very thin, made of gas particles that are basically so tiny you can't really see them. You need to look in specific wavelengths to actually see them, but you can't see them too much. But its magnetic field is very big. It goes up to the orbit of Saturn, which is gigantic, and it's also very extreme in terms of radiation, of how much is it actually. Now Jupiter, just for reference, doesn't get the particles just from the Sun. He also gets it from another source, which we're going to talk about a little bit later. But Jupiter itself is the biggest planet, the biggest planet in terms of volume and mass from all the others, and is the big boss of the solar system beside the Sun. Now Jupiter has the famous red spot that we all know. It's a gigantic storm that basically is really visible, but when it first discovered by the Voyagers in the early 1980s, sort of 70s to be more exact, then it was very big and very lopsided, which means it was more like ellipse than actual circle. But over the years, more and more observations show that the storm is shrinking and getting wider. Now the wider it gets, the less stable it becomes, and eventually it will be destroyed in a course of, could be hundreds of years, could be more, we don't know for sure, but it will be we're gonna lose eventually the Great Red Spot. Now at the end, Jupiter has a very interesting dynamic with lightning storms, just for reference, and the fact that his poles is where most of the action in terms of lightning and extreme conditions are actually occurring. Plus, if you look at it magnetically in terms of how the lines are arranged, it has basically a south pole, a north pole, and also an equator pole that basically is an anomaly that is caused because of the planet's structure. And the planet itself is made of gas, and gas, unlike solid rock or ice, isn't that stable. That means that no matter how much the electric field is going away, eventually some of the magnetic lines will be tangled and twisted and could create this kind of anomaly that we see. This anomaly is called the Great Blue Spot because it looks blue. If you look at the magnetosphere maps, if you look at it through any other thing. Now, I'm gonna talk and show a little bit about it because we do want to see. Now, if you're gonna see a little bit, I'm just gonna try and show it. It doesn't open too much, but it is how you can see. The Great Red Spot is right here, and it was filmed in February 12, 2019 by the Juno spacecraft, all in all. Now, there is a view in 3D, if you want, of course, it's from NASA, but the thing is, this is Jupiter basically. It has a bunch of moons we're going to talk about. We're going to talk about the main ones today, but yeah, that's a little bit of them. And overall, it has a lot of things. Now, we know that it's a gas giant, but it has made up mostly of hydrogen and helium, which are the most common gases in the universe, and has more than 75 moons, and has superstorms and great storms, and even have rings, like we mentioned, that you can barely see. Now, another thing about Jupiter, which you should know, and I will try to explain it as well, is the fact that it basically very much straightforward on its axis, which is instead of tilted axis like 20 degrees, 30 degrees, 60 degrees, it's basically almost straight up. Very few degrees, if so, in terms of how much it tilted. And its density is about 1.2 or so, 1.3, so, or 1.1. It's density pretty low because, again, it's made of gas. Now, besides that, there are of course more things about Jupiter that we should know about. But, just for some reference, we're gonna show you a little bit in terms of size comparison to the Earth, of course, considering how big it is. It can contain over 1,000 Earths inside. And in terms of the structure, you can basically see how it goes. There is a ring, again, dust ring, and there is the Great Red Spot, and there is a bunch of other things like cloud layer, aurora, a bunch of stuff. So it's very important it has all of this. This is a little bit of a structure, including some of his moons. Now, of course, if we're gonna look at this time lapse, you can see that the Great Red Spot was much bigger when Voyager 1 was flying towards Jupiter in 1979. It was much more elongated, more elliptical than circular, but yeah, it was. And here, for example, you have this is basically the south pole of Jupiter with a bunch of storms in it. And this is the Great Red Spot, of course. This is white ovals, which are also storms on its surface. And of course, this is the magnetosphere auroras that are basically caused by the sun's radiation and by another culprit. And you can see it very well. Now this point, if you can see it, this point is basically the point where the particles, the charged electrons, are actually touching the magnetosphere and goes around. This creates the giant auroras that you can see today. And now this is just, again, this is in June, this was made in June 2016, but it was still showing pretty well. Now, all in all, you can see even the infrared of the southern lights on Jupiter. It's very intense, like really intense. Again, this is the same idea. And overall, this is how Jupiter looks through an amateur telescope with its moons, just for reference. So again, I'm not gonna go dive too much into it, but it was visited by a couple of things, and those are his moons, which we're gonna talk about a little bit later. Now this I wanna talk about to find some kind of event if you wanna hear. This is the Shoemaker-Levy 9 comet. Now I will explain about it a little bit here. This comet struck Jupiter in 1994, and it was struck in a bunch of parts. It broke into several parts. It struck Jupiter in a specific angle at the same area, if you will, around the planet. And as the planet spins, you could see the dark spots where the comet struck the atmosphere and made some gases go up into the upper atmosphere from inside Jupiter itself. And it left those black marks, which you can see right about here, just for an example. Now, besides that, we're not going to talk more. We're going to go and talk about his moons. Now, Jupiter has over 75 moons. However, we're going to talk about the main 4 moons: Io, Europa, Ganymede, and Callisto. Those 4 moons are his biggest moons, and Ganymede is the biggest moon in the solar system. It's even bigger than Mercury, which is the smallest planet we have in the solar system. Now, Io is the first member of those 4 Galilean moons, which were discovered by Galileo Galilei in 1610 through his telescope. He could see them as 4 dots in the equator of Jupiter in a way. Now, this is the closest moon to Jupiter from those 4 big ones, and it also suffers the most in terms of how much force is on it in a way. Now, when Io moves around Jupiter in an elliptical orbit, not a circular one, he's basically pulled through Jupiter's gravity towards him, but also he's affected by the other gravity from the other moons like Europa and even Ganymede. Now, it causes to stretch and pull in his orbit, which in turn is hitting his inner core and creates magma chambers, which go through the surface in volcanoes. Now, Io is the most active body in the solar system, with over 300 volcanoes on its surface, and actively spewing out materials like sulfur, carbon dioxide, and a bunch of other gases into it. Now, when I said that Jupiter gets his charged particles not just from the sun's particles that goes into his magnetosphere, but also from another source, I meant to Io as another source. And Io spewed those electrons, charged particles from the volcanoes, from the plumes. They have been cut by Jupiter's magnetosphere and goes into his poles. Now, this creates the auroras and are much more intense than they would have been otherwise. Now, Io was also called the pizza moon because of its strange colors, and I'm going to show you a little bit about them right now. Now, those colors are what basically creates this pizza face, if you will. And there's a bunch of volcanoes, and each color basically represents sulfur and a bunch of other materials on it. Now, this is an old picture from 1999, but there are more recent one, of course. There are size comparison to it. It's smaller than our moon, but still extremely active. And there's even, once again, a bunch of volcanoes on it, and you can see the coloring, which means those are active volcanoes spewing materials in a way that is not just that. Now, if you're gonna see here, you see the size comparison. Now, this is Io, this is Jupiter, of course, and you can see the size difference. It's a tiny moon compared to the planet, but it's the closest of the 4 major moons of Jupiter. Now, again, we have also another picture from 2023, also shows some of its surface, and you can see also a bunch of volcanoes, and again, the surface is covered with sulfur, carbon dioxide, and a bunch of other stuff that basically fell on him. And here we can see something very interesting. Now, his main planets, Ganymede, Europa, and Io, are in a resonance orbit. Resonance orbit means that for each one of Io's orbits, Europa does twice, and Ganymede does 4 times. This was also happening to Jupiter in the past, but just for reference. And now this is just an example of his magnetosphere, and you can see that the charged particles go from Io into the poles of Jupiter through the magnetosphere, just catching them and dragging them right into that area. And this is creating as much stronger auroras than usually would have been. Now, this is possibly how his inner core layer looks like, but we're not sure yet, of course. But you can see basically there is a volcanic plume, sulfur dioxide aurora, lava flows, there is a bunch. And you can see here, for example, the lava that is inside because of tidal heating, which is the thing I will explain in a moment. But this even explains over here, tidal heating is caused, and I will explain why in a little bit more, but There is even this, which is a full map they made of its surface, and a bunch of other stuff like specific volcanoes. You can see lava flows. It's very, very active moon, and here you can even see a plume that goes from the volcano up and about. So it was very intense. And not just that, it goes 330 kilometers above the surface, which is very, very high. Now, we'll explain it like this. Why it's so high? Because specifically, Io doesn't have an atmosphere, so there is no limit of how far it goes. Now, I will go a little bit about the other moons, and I hope that you can understand. Now I'm going to talk about the second moon, which calls Europa. Europa is an icy moon, the second moon from distance, also has an elliptical orbit like Io, also tidal heating, which heats its core and everything, but there is a difference. Unlike Io, which has a molten crust underneath his iron, underneath his rock crust that covers it, underneath it has a magma core. Europa, on the other hand, doesn't have magma underneath, it has water. The moon is basically a giant ocean covered by ice, a thick layer of ice. Why? Because when the moon is heating up, the ice underneath is melting, and when it's melting, it turns into water, and you get basically an underground ocean. Now, we don't know for sure if it's the case, but it most likely is. Now, if you look at Europa from any telescope, you will see something that is not that it's familiar, because it looks like fractures on the surface. If you see those fractures, you can basically see it's like a giant glacier that basically goes under, on top of the ocean. Now, this is basically from Juno's flyby, and it's basically it's in October 2023. Now again, it also has the same resonance that is basically on Io. It's the same thing, it only does twice compared to Io's one, which is also the same. And again, it's a tiny moon. It doesn't go, it's very smaller than our moon, but it has water on it, or at least most likely it has water on it. As you can see, the area is cracked like the glaciers in the North Pole of the Earth, basically, because we know that if it shows signs like this, it means there is something liquid underneath, and most likely it's water, because it's basically water ice. And here you can see even more of the surface. It's very, very interesting moon. Why? Because again, as you can see here, most likely there is a water ocean underneath the icy crust, which is what basically is the most intriguing thing about this moon. And you even have more layers, areas. It looks like a cracked egg. So this is just a little bit about Europa. And there is also of suspected water plumes that might happen on it every once in a while through its orbit, because it heats up just as much as Io in many ways, but instead of molten rock, you have water ice that basically melts into water underneath the surface. Now the ice is very thick, tens of kilometers of thickness at least, so it's needs something very strong to penetrate through it and to actually see it, but right now it's an hypothesis that actually works. So this was it, Io. Now I'm gonna go into a different moon. This Ganymede is the biggest moon in the solar system. It's bigger than Mercury. It basically has big mass. It also has water underneath the surface, or at least it's suspected to have them. And plus, overall, it also has magnetosphere. It has magnetic field, which is weak, but it has it, and we found some of it. And plus, its surface is also very interesting and different than you might expect, as you might think. For example, I will just show it like here. This is traces of magnetic field that is basically shows on the surface, or in this case it has parts of magnetic field that's very weak, but you can see it. And this is it has a surface, most likely it has a saltwater ocean underneath, but we don't know for sure. But according to this result, most likely it has. Now again, if you can see it, it has a bunch of craters, but overall doesn't have too much. I mean, it has a bunch of craters, it has an interesting surface, as you can see, but It's the biggest moon we have in the solar system. And it's also the thirdest in terms of distance from Jupiter itself. Now here you can see it's bigger than the moon, but still not bigger than the Earth. But it's big, it's very big. And plus, overall, you even have some areas of it with pictures by Voyager too, but still you can see craters, areas, patches. Those patches, by the way, most likely are salts that came from a saltwater ocean or saltwater underneath. Just for an example. Here you can see a crater, and around you can see this white substance, which is most likely salt. And overall, again, you have another few craters here and there. It's a very big moon with a doesn't have much of an atmosphere, but it does have a magnetic field that does protect it, but it's a weak one compared to Jupiter itself. Here you can see the way that it shows how it may look through the layers, like saltwater ocean, there is ice, there is rocky mantle, and there could be iron and iron sulfide core or something, but we don't know for sure. But most likely consider what we can see on the surface through pictures. Even temperatures, which are very low, by the way, it's very cold, and here is the interesting part. This is the magnetosphere. As you can see, this is it. This is Jupiter's. Jupiter is all around it, but here you can see the magnetosphere itself. It's weak, it's tiny, but still, it's there. It's working. It also creates some lines. Here you can even see auroras, which indicate something interesting on it, and so on. There is a bunch of things, even a bunch of other stuff. So this was a little bit about it. It's the biggest moon, it's the biggest thing we know around Jupiter basically, and it's also the last one from the 4 major moons that actually is in some kind of elliptical orbit and is influenced by the other moons in Jupiter itself. Now this was a little bit about them. Now I'm going to talk about the last one in this system, which was the last 4 from those 4 big moons, Callisto. Now if we're going to go to Callisto, is the most peppered moon in the solar system. It has the most craters, it has the most literally battered surface. It was battered by craters, it was bombarded by asteroids for a long time. But what makes it a little bit unique is the fact that basically it's the only moon from the 4 big moons that is not affected by the other moons in the system, the other 3 moons, and is the least affected by Jupiter, because it's also the furthest from those 4 moons. Now again, it was discovered with the other moons and with Jupiter in 1610 by Galileo Galilei, but overall it's the least interesting moon, let's say, of the bunch, but it's still a body we can talk about, and just showing how it is. When I say battered, I meant battered. This is the most battered moon in the solar system. You can see it is peppered by craters from all angles, from all the stuff, and it's just literally peppered like no other moon can ever be. This is for example. Now again, if you can see from the very tiny place, Callisto is the bottom left. It's from here it is. It's so tiny and it's far from the other moons. Just one example. Now if you can see, it's bigger than Earth's moon, but still not as big as Ganymede, for example. And most likely it might also have saltwater ocean, but we don't know for sure, because it has a bunch of craters and it's kind of hard to see exactly. But it could be, considering a bunch of other facts about them, because it's a very ancient surface, doesn't change much, it just shows a lot of craters and this magnetic field around it, which is pretty weak, but it is. There is a tiny one because it's a pretty big body, and overall you can see there is a bunch of other stuff on it. Now at the end of the day, this moon is basically a good stop. It has most likely water on it, so we can expect it to be able to, we will be able to get it out in some way in the future. It could be a nice pitting stop or a stop before we're gonna go beyond to Neptune, Uranus and beyond. At the end of the day, Callisto is the least interesting of the 4 moons, but also an interesting body by itself, because it basically peppered like crazy with craters, and also a very big body with also water that most likely is underneath, but we just don't know until we're actually gonna get there and dig and see what we can find. So I hope you enjoyed this video. This was a video about Jupiter and the 4 moons. I tried not to go too deep, but I hope you enjoyed it, and I will see you in the next video. Goodbye.